Okay, this is going to be a pretty short mini lecture, kind of just introducing you to the idea of electrical components. Specifically, those components that were going to be important to us as we analyze circuitry. So we're moving from our idea of static electricity to flowing electricity. So what we kind of commonly think of as electricity, the stuff that turns the lights on and charges your cell phone. So we want to talk about that kind of electricity, and it's super fun. We first have to understand a few questions. We want to understand what electricity is in this framework and how it happens and what's required for it. And that's how we're going to talk about the components. And then later videos are going to introduce each of those components in a little bit more detail. If you have not grasped yet the ideas of forces and static electricity, static forces, electric fields, and electric potential, I strongly encourage you to look at those videos first. They are all in this same playlist. We're just going to make an assumption that you have a good, solid grasp of that material. Okay, so what is electricity? In its most kind of generic form, the electricity we're going to be moving forward with is really the flow of charge. So the flow of charge, and again, we use that for so many different things, right, in our world. So we have to understand, how does that work? How do we get charge to flow? 3 questions are going to answer that for us. 1, does the charge exist? So what is the charge that we're talking about? 2, why does it move? Because we have to make sure that it does move to get a flow. And then 3, how does it move? What's required? Okay, so that kind of idea is it has to exist, charge has to exist, it has to be motivated to move, something has to be causing it to move, and then it has to be allowed to move. Okay, so what, why, and what allows it to move. All right, so what specifically flows to begin with? So what is the charge that is flowing when we are talking about electricity? Well, we've learned that the flow of electricity in our experimentation, the big we, is that what's actually flowing is electrons. When we look at how electrons are bound to molecules, electrons are much more loosely bound to molecules, especially those in the outer layers of the electron shells, than protons. Protons are really hard to move from one molecule to another, but electrons can move freely. In a lot of cases, they can be stripped off. Remember back in that discussion of static electricity, they can be sheared off of a molecule. And if allowed, they can be shared, right? They can move within a conductor, right? So the charge that is actually moving in the flow of electricity is in fact the electrons. Okay? And so a couple of things about those electrons. We know, of course, that they are negatively charged. And these are the free electrons that are flowing. So that they can move through conductors. So that's going to be an important thing to keep in mind as we answer more of these questions. Now, the flow of electrons, this is what we call a current. So this is that flow. And we're going to get in details of what current really is from a description standpoint in the current video. Current not meaning now, but current meaning current. All right. So we know the charge, check. Why does it move? Well, why do charges move? Well, they feel a force. We learned that in static electricity. And that force can come from an electric field. And then we also learned that electric fields and electric potentials cause charges to move. They're related, right? And so in the case of electricity, what we provide in the case of electricity is an electric potential. And more specifically, the electric potential difference, right? That's what's important to get charges to flow. When there's a potential difference, charges will flow between them when placed in that potential difference. That potential difference, remember, is the voltage. So we make sure that there's a voltage, a potential difference for charges to be motivated to flow. And often, and what we will use in our most discussion, is this is often what we think of as a battery, right? The battery provides the voltage. You have a 9-volt battery or a 3-volt battery, right? Provides the voltage. More generically, we call this an EMF. And that stands for electromotive force. So that is another name that you're going to hear. We're going to typically use a battery as our example. It's providing the potential difference, the motivation for these charges to move. Okay, so they move because charges are placed in an electric potential. That means then that the charges actually have to be between the high and low potential of the source of that potential and able to move within that space. How do electrons move? Well, they have to be in a conductor. So the last piece is a continuous line of conductors. And that serves two purposes. First, it provides there to be an electric potential in existence across to an area, that area being the continuous line of conductors. And it allows those electrons to flow freely through that conductor, to move, because they can move in that conductor. And of course, our continuous line of conductors, these are our wires, all right? But they have to be continuous. There are two names. If they are continuous, we call that a closed circuit. And that is what we need. Circuit meaning loop, a closed loop, okay? This is good. However, if they are not in a continuous line, if something is open, there's a break, we call that an open circuit. That's bad. It will not work. We won't get the flow of electrons. So, continuous line of conductors provides the means for electricity to flow. The electrons, of course, are what are flowing through that continuous line. Those free electrons are free to move within that line of conductors, and what motivates them to move? We have a potential difference from the beginning of that continuous line to the end of that continuous line. All right, so that's sort of the basic idea of our circuits. We're going to talk about very specific elements. What provides that potential? What is this about the batteries? What does that look like? What is the current really? And then we're going to add a couple more elements, resistors and capacitors, before we look into simple circuits. All right, nice job.